Welcome back, math people. We are moving into part 2 of our adding and subtracting rationals. We'll even name it part 2. There we are. All right, today we're going to handle adding rationals that have different denominators. Okay, so first of all, let's throw in the pizza example, just so we have one more reminder of what in the world is going on. These 2 and 3, these are units. Okay, one's feet, one's inches. You can't add them if they're different. You've got to get them to be the same number. So we're talking about the same size of things, of whatever we're talking about. We do this by finding something called the least common denominator. Common in that they both have it. Least in that we're not looking for millions and billions down in the denominator. We want small denominators that are easy to work with. Okay, the LCD, or the least common denominator. What's the smallest number we can multiply a 2 and a 3 and have them be the same? Well, probably I'm going to say a 6, because 3 can reach 6 and 2 can also reach 6. So that's our goal. That's what we want the denominator to look like. So how do we get this guy to look like that? We times him by 3 over 3. And the reason we do on top and bottom is we're timesing him by a strange version of the number 1. Like, we could cancel this right now and stop everything, but we don't want to cancel 3 over 3. We want a 6 over there. So that's why we do 3 over 3. It's really just a timesing by the 1, so it's an equivalent form. It hasn't changed the value. So how do we get the second fraction to be a 6? Well, probably a 2 over 2. Okay, and this will turn, the first fraction is going to be 3 over 6 now. That's still 1/2, but now we're talking about the same size of pizza slice. Okay, and now we've got 2 over 6. So now we can actually add them and have something that means something valuable, as opposed to 5 feet plus 3 inches equaling 8, or something weird like that. Okay, remember, the denominator doesn't change. It's just tracking units. So it's not actually adding, it's just tracking things for us. Okay. First thing we're going to do is we're going to find the least common denominator. Step 1 in doing this, in the denominator, the bottom of the fraction, if you can, we're going to factor this. Now, this mainly applies to groups. If you don't have a group in the bottom, you kind of skip this step. Okay, so step 2, whether you have a group or don't, here's what we're looking for. We're looking for lone numbers. It's actually kind of the same steps you use when you're looking to cancel things. We're also looking for lone, I'm going to say x's because it's easier to write, but I mean variables. So x's, y's, j's, z's, anything like that. And finally, we're looking for lone groups. Okay? So factor first if you've got a group. If you don't have a group, then you kind of jump to step 2. Okay, so the first thing you're going to see on your assignment is just finding a least common denominator. Okay, that's all we're doing, is finding a least common denominator. And remember that in the denominator, you're going to find a group if it's got a plus or a minus running around in a single denominator, not between the fractions, just in a single denominator. Okay, we're not actually going to do the full adding. We're just going to figure out what's the goal. What is the least common denominator going to look like? Okay, we've got 2 lone numbers, a 7 and a 4, and the smallest number they can both reach is a 28. So that will be in the denominator. Now, the next thing we're going to look for are lone x's. And the variables are actually really simple in least common denominators. You're just going to make a list of them. So we have an x. There it is. Okay, so lone numbers is the same as it's always been in fraction. Lone variables is you're going to make a list of them. And if you have more than one with different exponents, you want to grab the highest exponent. Okay, now we only have a single x, so that's the one we grabbed. Okay, and then the 7 and the 4, that's where the 28 is coming from. And that is the least common denominator. We are now done. Okay, we're not doing the full problem. We're not actually going to add them together. We're just looking for, hey, what is eventually going to be on the bottom? That would be on the bottom of the fractions we would combine. Okay, so we're just practicing finding the least common denominator. This is the first thing you're going to run into on your worksheet, is just finding it. Okay, next problem. Factoring, again, only really applies if you've got groups. These aren't groups. Okay, these are lone numbers and lone variables. We don't have a group yet. Okay, we're getting there, but we don't have one quite yet. So all we're looking for is the goal, the least common denominator. What's a unit they can all have? Okay, lone numbers. Well, I've got a 7 down here and I've got a 1 down here. It's hidden. I just drew it, but yeah, it's there. So a number they can both reach is the number 7. Okay, so again, and if it helps, cover everything else up. Look at just the numbers. Pretend those are just 7s and 1s, and you would get them to become a 7. Okay, now this is what I was talking about with the variables. Okay, you have an x cubed, and then the other one you've got is an x squared. They're both x's. Okay, so we know we'll have an x, and of the two x's that we have, we want the biggest one. We want the x cubed. Okay, so if you've got the same variable, like 2x's, 2y's, 3y's, 8z's, whatever, grab the variable that has the biggest exponent of that variable type. Okay, and what would happen is we would make that 7x squared, we would hit it with an x, and it would match the other variable. So you're matching numbers, you're matching letters, and eventually we're going to be matching groups. Okay, we would hit this first fraction with a 7, and we would hit that second fraction with an x, and then both fractions would have 7x cubed on the bottom. We're not going to take that step quite yet. We're just saying this is what's going to show up on the bottom, just to give you an idea of how this is going to be used. Okay? Alrighty, over here, I see groups. Okay, I'm going to hide the groups in their parentheses so I don't accidentally start canceling things I shouldn't be canceling. Okay, we've got lone groups. Now the first thing we're going to do, especially since we've got a group, is we're going to see if we can factor it. Sometimes you can't, but this group can be factored. There's a 5 in that we can pull out. That'll leave behind a 5x plus 3. Now the 10 doesn't really do anything. He just sits there because he can't pull anything out. Okay, let's play with the lone numbers. We have a 5 now. He is now a lone number. We also have this 10. Okay, I'm going to scratch that off just so it doesn't confuse us. All right, what is something both a 5? Okay, again, if you need to cover it up, what can something a 5 and a 10? Okay, what's something they can both reach? Well, probably a 10. If you hit the first 5 or the first number with a 2, it becomes a 10. All right, lone variables. We do have no lone variables. There is an x, but he's part of a group, so he doesn't count as a lone variable. Speaking of which, we've got a group. Now the groups work a lot like the variables, so they're also pretty easy for least common denominator. What you do is you just make a list of all the groups you find on the bottom of these fractions in the denominators, because it's a least common denominator. So you're always looking at the bottom here. So I'm going to list x plus 3, because he's in the bottom. So the numbers, you find the number they can both reach, but everybody else, you just make a list of them. You list the variables, you list the groups, and that is the least common denominator right there. Okay, there it is. 10 times the group x plus 3. All right, last one for just least common denominators. Protect your groups. Okay, don't let anything get to them. Don't randomly cancel things you shouldn't be canceling. Because these are groups, let's see if we can factor. X plus 4, no. 2x plus 1, nothing in common there either, so that's also no. 8x minus 3, you don't want to factor numerators. Leave the numerators alone for this part. All right, let's look for lone numbers. No lone numbers in the bottom. Again, you're just looking at the denominators. Okay. Lone variables. No, we got variables, but one's in the numerator and the others aren't alone. Okay. So again, make sure you're looking at the denominator. So yeah, there's a variable, there's a 4x, he doesn't count. Okay, lone groups. We have 2 lone groups. We're going to list each one. Okay, so in our list of our least common denominator, there's an x plus 4 group, and there's also a 2x plus 1 group. And that's it. That's our least common denominator. Okay, there were no numbers on the bottom. There were no letters, lone letters at least, on the bottom. So that's it. Okay, and again, you're just listing them. The groups and the variables. Those are the easy ones. Now the next part, we'll figure out what we do with them. All right, this is it. The craziness will happen. We are going to do the full problem for adding and subtracting irrationals. We're actually going to do it. This part, we're going to start with things that have monomials in the bottom, so no groups in the bottom. There is a group up top. That's okay. Because once we figure out what the least common denominator is, which is the first part of this problem, because our denominators do not match. We're looking at feet, height, inches, yeah. We're looking at different units of measurement. Okay, again, you're looking at the denominators. Make sure they match. Numerators, they don't need to match. It's the denominators that have to match. Okay, and this is what you look for. It's the same as what you look for in canceling. We're going to look for lone numbers. We're going to look for lone x's. And we're going to look for lone groups. Those are, again, in the denominator. Things that are adding or subtracting in a single fraction, not between the two fractions. And we don't have matches. We have a 4 and we have a 5y. That is not the same number. So we're looking at our lone numbers. We're finding our least common denominator. A 4 and a 5. What's the number they can both get to? A 20. Okay, now we're looking for lone variables. There's a y. So the lone variables, you just make a list of them. I've now listed that, yep, I've got a y down there. So you're just making a list. Okay, so that's, we did that in the first bit, okay? Now we need to make it match, okay? How do we get a 4 to turn into 20y? Okay, well the 20 part will need a 5. And the y part, you get a y. Okay, and remember it's top and bottom because it's canceling to the number 1. Okay, we're making an equivalent fraction, not a different fraction. So on the bottom, okay, the 5y times 4 is 20y. So that's a unit that both fractions can reach. Now on the top, we're going to distribute into the group, okay? And this is something you'll do on numerators only, okay? In the denominators, when we get groups going, we're not going to distribute them. We're just going to leave them as groups. But the numerator, you want a single group, just one group in each numerator. Because when you're adding or subtracting, you don't want a lone number outside the group trying to multiply, because that's going to preempt your addition and preempt your subtraction according to PEMDAS. So you want a single group. So we're going to get that 5y into the group and make a new group. So we have 5xy minus, and that one's going to be 20y squared. Could also be 5yx. tend to put them in alphabetical order because reasons? Just what I do. Okay, second fraction. We want to match the least common denominator. That's why we create it. That's our goal. We want the denominator to look like that. And I think we just need a 4. He already has the y, so we just need the 4. Okay, there's that addition sign. And now let's consolidate that, see what we get. We should have 16 over 20y. And now we have matching denominators. So the least common denominator provides us a match that both fractions can reach. Okay, and remember that when you add these, the denominator does not change. That's a unit. It's tracking how big they are. Okay, so it doesn't change because what changes is the amount, not their size. And now we're just doing the like terms part. We have a 5xy, a negative 20y squared, and a plus 16 because there are no like terms. Okay, and when you add these, we have created a brand new group on top. It does have a y squared, so there's a possibility it can factor, but in order to factor, you kind of need a y squared, a y, and a constant. And there is a y squared, there is a y, but then there's this random x. The x is kind of fouling it all up. So this thing doesn't factor, and the numbers have nothing in common outside of a 1. So that guy's pretty much done. The 20s don't cancel, the y's don't cancel because they are part of the same polynomial. All right, this guy. Now this guy we can be a little tricky on, okay? Because it does not have matching denominators. That means we don't have to keep stuff around if we don't want to, because they don't match. We can mess them up if we want to. So we're going to see if reducing and canceling helps. Sometimes it does, sometimes it doesn't. We're going to see one where it doesn't help. But in this one, it does help. So these x's can cancel out, and so can these x's. And what that will do, it means there's no x's left in the entire problem. We don't have to worry about the x's at all. 15 over 6, you can pull a 3 out of both, and there's no x's in that fraction. It's awesome. 6 over 4 is going to go down to 3 over 2, and there is that y squared still over there. And now by canceling these fractions independently, okay, and they don't cancel like multipliers do. You can't cancel the top of one with the bottom of another. That's only for multipliers, okay? Addition doesn't let you do that. But rather than working with 6x and a 4xy squared, now we're looking at a 2 and a 2y squared. This is going to be an easier least common denominator, an easier LCD. Okay, let's look for low numbers. We got 2's. Can both 2's reach the number 2? We sure hope so because they're already there. Lone variables. There's a y squared and the other guy doesn't have anything, and we're just listing them. Okay, so there's just a y squared. Now, if the x was still in it, we would also make a separate list for x. But the x canceled. Now, if you didn't see it canceling, this actually still works if you don't cancel it. Also, there's no groups. It's just that you do a lot of canceling at the end. Okay, so let's turn these fractions into things with that denominator. So the first fraction needs a y squared to make it look like 2y squared. So we get 5y squared over 2y squared plus... And we need to make the second fraction. His denominator needs to have a 2y squared. Oh, sweet, it already does. We don't have to do anything. Yay! So if the bottom already matches, you're done. You don't have to do anything. So we've got matching denominators, and we're adding, so we need matching denominators. And it's really tempting to want to cancel those y squareds. Don't, because then you're back where you started. Once you have matching denominators, don't cancel anybody. Go for it. Add them. Don't cancel. Just add them. Okay? So here we go. We're going to add our like terms, which is not a whole lot of work. We have 5y squared plus 3, because those are not like terms. And then we have a 2y squared. We have formed a new group on the top. I'm going to put him in parentheses to protect him, just so I don't accidentally cancel things, because those y squareds don't cancel. You cannot cancel parts of a group. Okay, and that's a group on top. Yeah, they're y squared on the bottoms alone, but yeah, there's a group on top. Nothing comes out of that group, so 2 doesn't have anything to cancel with. Y squared doesn't have anything to cancel with. That's it. That one is also done. All right, and that is how you add and subtract fractions with different monomials in the bottom, or in the denominator. All right, we are on to the last part of adding and subtracting these rationals. We've got a group now in the bottom. Oh, no. It's going to be okay. All right, let's look back, because the first thing we're going to do is find our LCD. But if you've got a group, you want to see if you can factor it, because if you can, it will make the math a little bit easier in the long run. And this thing factors. We can pull a 2 out of that 2m minus 6, and that'll leave behind an m minus 3. Remember, you're dividing it out, and you should be able to distribute and get back to the original. We have successfully factored that. We can get back to the original. Okay. It looks like we could cancel these 2's. In fact, and it doesn't even look like it. We could cancel those 2's, but here's the problem. It's not going to help, because there's a lone 2 in the first fraction. That means there will need to be a lone 2 in the second fraction. So in this instance, it actually doesn't help to cancel it, because we'll have to bring it back. Speaking of least common denominator, lone numbers, there's a 2. Let's look for lone variables, not in the denominator. Yeah, numerator, not denominator. Okay, groups. There's a group. Groups are easy. You're just going to list a group if there is one. There is one, so there it is. Now the least common denominator is a goal. Okay, we want the bottom of the fraction to look like that, and if we don't cancel the 2, the bottom of our second fraction already looks like that. So we're done with that second fraction. So sometimes you don't want to cancel them. Okay, now how do we make the first fraction look like that? Well, it's kind of like when we were playing with complex numbers and we multiplied in a conjugate. You're multiplying in the group. So if we need an m minus 3, we multiply it in. Okay, now in the denominator, we're not going to distribute that. We're just going to let it sit there as a 2 and an m minus 3, because the denominator doesn't have to do any adding. It just sits there. But the numerator needs to add, and in order to add, we need to make that a single incorporated group, which means we need to go ahead and distribute the 3. So we want a new big group. So 3m minus 9, and it does distribute. Okay, so that's a new group on the top there. Okay, we're adding just the numerator, not the denominator, because the denominator is just like a unit. So 2m plus 3m, and then a minus 9 out back. And the denominator just comes along for the ride. So still a 2 and an m minus 3. Okay, that is a new formed group on the top, but nothing is going to come out of it. I'll go ahead and put it back in its parentheses, but there's nothing factoring out of that. So that guy is done. We have concluded that problem. So let's take a look and see what happens when you've got different groups in both fractions. And it's subtracting. Just for, fun, because why not? Okay, first of all, we're going to go looking for the least common denominator. Let's make sure we know where the groups are. There's an n plus 5 group, there's an n plus 4 group. And factoring, yeah, I'm not seeing anything that can factor out of this. Okay, lone numbers. No lone numbers. Lone variables. No lone variables. How about groups? We got groups. In fact, that's the only thing we do have. There's an n+4 group. There is also an n+5 group. So you're just listing what you have out of both denominators. Okay? So we just made a list of it. That's what's in the bottom. Not the top, just the bottom. So how do we make the first fraction look like that? We give it the group it doesn't have. Okay, it's got the n+4. What it doesn't have is the n+5. Okay, the denominators, just let them sit there and stare at each other. Okay, they can be weird that way. On the top, we're going to go ahead and distribute that 4 through because you want a brand new group on the top that isn't like a group and a number or a group and a letter. You want all one group. So we have 4n plus 20. And that's our new top group. Okay. Second fraction. We have an n+5. We want an n+5 and an n+4. So we basically times in what it's missing. And it's missing the n+4. Okay, and remember top and bottom because it's just a very strange version of the number 1. Okay, so the second fraction, don't lose the subtraction sign. Make sure you know what operation is linking these two fractions. Okay, on the bottom we now have what we want. The parenthesis n+5, the parenthesis n+4. Order doesn't matter really. Okay, and on the top that is going to distribute. So we have 3n squared plus a 12n. And that's a new group. That's a brand new group up there. Okay, the subtraction sign. This is where we distribute it into that brand new group. So the 3n just turned negative n squared, and the 12 just turned negative. Okay? And since we've distributed the negative, we're now just combining like terms as though we were adding. Okay, so on the bottom, we still have our n+5 and our n+4 because the bottom is just tracking the size of the piece, not the amount of the pieces. It's just saying, oh yeah, they're all this size. Okay, common denominator is down there, and like terms, there's an n squared with no friends, 4n and a negative 12n, because it's negative because it distributed. That's a negative 8n. And still on the numerator, there's this 20 is a positive, and there's no other solo numbers. Okay, we have a new top group. Excellent. Now, at this point, this is where you say, hey, can this factor? Because look, there's an n squared, an n, and then a nothing. That's exactly what you need for things to factor. The question is, can it? Not everything can factor. So here's a quick way to check to see if something can factor. Okay, we're going to check to see if it can factor, and we're going to go back to that b squared minus 4ac that we learned about last unit. Okay, so it goes abc, and we're just playing with the numerator. So b squared, that's the negative 8 times negative 8, that's 64. A is a negative 3, the signs matter. And c is 20. All right, so we've got 64, and then the negative 4 and the negative 3, that's actually going to become positive. They'll cancel. And then we just have 4 times 3 times 20, which happens to be 240. Okay, and we'll add those together. We've got 304. It's positive, which means there's 2 real answers, but we're not looking for what kind of answer it is. We're just wondering, can this factor? And the question is, does 304 have a square root? If it has a square root, it can factor. If it does not have a square root, don't try to factor it. It doesn't factor. So that's one way you can check to see if a problem factors. The question is the discriminant a perfect square? And the discriminant is not, which means it cannot factor, which means that's your answer.